Here we are at example 4 from our 3.8 number 2 set of notes. We're asked to graph this following rational function. And in just looking at this, we do notice that we have a polynomial on the top that we can go ahead and maybe factor. Actually, I think before we do that, what we'll do is look at first the horizontal asymptote and determine what that is. So because we notice that the degree on top is larger than the degree on the bottom, really this is x to the first, this actually will not have a horizontal asymptote. So this would be none. We can't definitively determine if there's a vertical asymptote or not yet because we would have to factor this. But what we can do is look for the slant asymptote. So for our essay, we notice we can actually find the slant asymptote too, by the way, because our degree on top is one more than the degree on the bottom. So we actually can go ahead and find that slant asymptote. Using synthetic division, we have -2 inside of our box, and then our coefficients are 1, -3, and 10. So again, just looking for that slant asymptote. First number drops down. 1 times -2 comes out to be -2. Adding going down, we end up with -5. -2 times -5 comes out to be +10. In fact, actually, this last coefficient is -10. And as a result, we end up with 0. So now our slant asymptote is y equals 1x minus 5 remainder 0. Now if we just go ahead and factor the top out, we end up with x minus 5 times x plus 2 over x plus 2. And we notice right away that that x plus 2 is on top and bottom, and those can both be canceled out. So anytime that you see that cross, essentially what that happens is you still can't have the bottom be equal to 0, but instead of a vertical asymptote there, that x plus 2 that did cross out instead becomes that hole that we've been seeing from class. So solving for x in this case, we see that a hole would happen at -2. Again, the bottom cannot be equal to 0 every single time, even if it does cross out like this. And the point here is to figure out for what x value is that happening at. We see that it's at -2. Because there's nothing left on the bottom at all, we actually have no vertical asymptote. So this will be none. If there was like another binomial here, or x or something, like another variable, then maybe we would have that vertical asymptote. But because everything again did cancel out, there is no vertical asymptote left over. Looking now for our x-intercepts, we just take our simplified version of the function. So in this case, we have, again, looking for x-intercepts. We take that simplified version, and if we're trying to cross this x-axis, finding those x-intercepts, we just have to set our f of x equal to 0. The reason for that is, again, every single time, if it is crossing this x-axis, the y values are always 0. So, for example, right here, it'd be -6, 0. Here would be -4, 0. Here is 0, 0, 2, 0. All the y values are always 0. So that's why we're going to go ahead and set f of x, which is the same thing as saying y, equal to 0. Solving for x now, we would just add 5 to both sides. So it looks like x comes out to be 5. So for our x-intercept, comes out to be 5, 0. So 1, 2, 3, 4, 5. There he is. We're now at a point where we can go ahead and graph these items. We have no horizontal asymptote to graph. We have no vertical asymptote to graph. We do have a slant asymptote. So here he is. 1x minus 5. So it looks like we have a y-intercept of -5. And then a slope of 1. Moving on to our whole, we know that our x value is at -2, but we really have no clue what the corresponding y value is. So what we want to go ahead and do is actually throw this -2 into the simplified version of our function. So when we do that, we end up then with f of x, really actually f of -2. You're throwing -2 into the function that's left over is equal to -2 minus 5. Again, these items dropped out, they canceled. We're just using our simplified version of that function. So f of -2 comes out to be, looks like -7. So our whole is actually going to happen at -2, -7. So -2, -7, there's our whole. If we go ahead now and graph our final simplified version of this, oops, I thought I already did the x-intercept. There it is. If we go ahead now and graph our final simplified version, that f of x is equal to x minus 5, we see that it is having that y-intercept of -5 with a slope of 1. And so ultimately we can see that our line actually overlaps our slant asymptote. Now, this brings up a really good point in the fact that, well, how can that line literally be the slant asymptote? And it actually, by definition, comes out to be where you can see that crossing, much like the horizontal asymptote. And in this case, it's actually happening everywhere for our slant asymptote. So he is there, but it literally is kind of like replaced with the line itself. So he is there by definition, but you really don't see him because he's crossing everywhere. Okay, and that really gets into some deep level math. As long as you understand like how to piece these items together, you're going to be okay. But again, though, that is example 4 from our 3.8 number 2 set of notes.